Alright guys, welcome to this page of the notes, and what we're going to do is actually get to maybe my favorite thing in Algebra 2. I love what we're about to do because it introduces a method that I've really kind of grown kind of fond of, and if you talk to kids who have had me for Algebra 2, this will be one of the, if you ask them, what is the one thing you remember from Algebra 2, almost all of them will remember this method I'm about to show you because we kind of make it a lot of fun. Anyway, here's what we're going to be doing. You're going to be using the definition of logarithms, which I showed you on the previous page. We're not going to use the definition. I'm going to show you an easier way. But we want to use the definition of logarithms to rewrite each of the following as either an exponential or logarithm. What we want to do, remember, they're inverse functions, right? Exponentials and logarithms are inverse functions. I just showed you that on the previous page of the notes. So you need to be able to go back and forth between the two. Go from a logarithm to an exponential, and from an exponential back to a logarithm. Now, I tell you here to use the definition. You don't need to use the definition. What I've got for you is a really, really awesome method that I really like a lot. Like I said, if you ask kids who have had this course with me, Algebra 2, this is one of the things that they'll remember from it. And it's what I call the snail method. And yes, when I say snail, I mean those little guys that are real slimy in shells. Snail method. Now, we're going to use the snail method as a quick and easy shortcut. Is a quick and easy shortcut to rewrite exponential and logarithmic functions. Sorry, not functions. Exponential and logarithmic. We will use it for functions, but right now they're just expressions. Now, I apologize, my writing is a little sloppy. I just want to give you a real quick definition of what the snail method is, how we're going to use it. It's a quick and easy shortcut to rewrite exponential and logarithmic expressions so that we don't have to use the definition. We'll just real quick use the snail method, and I'll show you why I call it the snail method here right now when we do our very first example problem. Okay, the snail method works going both directions, whether you're, sorry, hold on, let me slide this over a little bit. Whether you have a logarithm, please notice that I have both, right? This is a logarithm, right, because it's got a log in it. This one is an exponential, right, because I have a base raised to a power. So this is a logarithm, this is an exponential. The snail method works for both of them. I'm going to rewrite this logarithm as an exponential, right, because I ask you to go from one to the other. So if you're given a logarithm, you're going to need to give me the exponential. Or if I give you the exponential, you'll need to give me the logarithm, and the snail method works for both of them. Now here's why I call it the snail method. You're going to love this. Oh, so much fun. These things are awesome. Okay, what you're going to do with the snail method is it works the same way both for logarithms and exponentials. You will always start with the base. So the base of my logarithm is a 2. So I start there. I have my base of 2. So I'll write my 2. Then I snail, or I work my way around the equal sign. So 2. And I work my way around the equal sign to the 3. So I have a base of 2. That 2, right, because I'm writing an exponential, right? Remember, I'm writing something that now looks like an exponential. So the base of the logarithm is now going to be the base of my exponential. I work my way around the equal sign. The 3 is now going to be the power that 2 gets raised to. So 2 to the 3rd. And then I keep working my way around the equal sign. So I work my way around the equal sign back to the 8. And it's going to be equal to 8. Right? So 2 to the 3rd power is equal to 8. And what you've done is you've taken what was a logarithm, right? And you've rewritten it as an exponential. Now here's the reason why I call it the snail method. If you just keep that little curly Q, right? Working around, and then you go ahead and draw yourself a little body and a little head and put a couple little antennas on this guy and an eye and a face, and you've got yourself a cute little snail. In fact, I like to call my snails Gary, and Gary likes to meow at you. Meow. So from now on, when you guys are taking a quiz or a test and I ask you to rewrite and you do the snail method, I fully expect to hear people now and then just kind of meowing, and I'll know that you just use the snail method. So we're going to use the snail method to do this. So let me show you how it works for the exponentials, right? Again, just like with the logarithm, right? We start with the base and work our way around the equal sign. Same thing here. I start with the base of the exponential, which is 15. So I'm going to have log base 15. Remember, I have an exponential, so you're going to be writing a log. You got to give me the opposite. I gave you a log, you give me an exponential. I give you the exponential, you're going to give me a log. And now I work my way around the equal sign. So it's a log base 15. I'm going to take log base 15 of 3,375, right? And then I just keep working my way around. That's all going to be equal to 3. And again, if I were to just kind of finish off my little curly Q and put this little antennas on this guy and give him a cute little face and call him Gary. And Gary likes to meow. Anyway, that's why we call it the snail method. It's a quick and easy way to go back and forth from logarithms to exponential functions or exponential functions to logarithms. Let's go ahead and do a couple more of these together here real quick. Here's what I got for you. I got another logarithm. I want you to rewrite the logarithm as an exponential, and it's going to require you to use the snail method. Again, say the snail method as high-pitched a voice as you possibly can. It's a ton of fun. We love doing it. So, snail method. We're going to start with the base, which is 4. Work my way around the equal sign. So 4 raised to the -4th power is going to be equal to 1 over 256. And you've given me the exponential. Easy, easy peasy. I love the snail method. It's so much fun. Here we go. I got another one. I've given you an exponential, so I need the logarithm. Start with the base. We're going to use the snail method to figure this one out. Log base 4 of 2. Keep working my way around the equal sign. It's going to be equal to 1/2, right? You're just making those little snail shells. Feel free to draw Gary in there if you want to. Remember, Gary likes to meow. He thinks he's a cat. Anyway, okay, here we go. I've got a logarithm. I want you to write it as an exponential. That's going to require the snail method. 4 to the 2nd power is equal to 16. Keep going. I got another one for you here. Snail method. I've got an exponential. You need a logarithm. I start with the base, work my way around the equal sign. So it's going to be a log base 4 of 64 is equal to 3, right? And the snail method is a quick and easy way to take that exponential and rewrite it as a logarithm, right? That's all we're doing. And again, you just use the snail method to do it. Base 3, work my way around the equal sign, so I'm going to rewrite it as an exponential. My base is 3, it's going to be raised to the 6th power, 729. And then one more just to kind of finish these off. I've got an exponential, so I'm going to rewrite it as a logarithm. Log of 125 of 5 is equal to 1/3. And again, if you just finish those guys off and draw yourself cute little snails. Remember, they like to meow. And so anyway, and sometimes they'll leave like a little trail of their icky sludge behind them. But they're cute, and they meow. Name your snail whatever you want to. And remember, snails like friends. That's why I almost always give them to you in pairs, right? These snails like to have friends. They don't want to be lonely. But snail method is a quick and easy way to go back and forth between exponential and logarithmic functions rewrite them. And it's not all we're going to use it for. You will see snail method in every single section from here to the end of the chapter. We're going to use it a lot. It's a real quick and easy shortcut that really helps us when it comes to exponential and logarithmic functions. So don't forget the snail method. We're going to use it a lot. All right, head on over to the next page of notes and we'll take a look at a couple more problems with logarithms. I'll meet you guys over there.